plus. If it's in scientific notation, what's cool about scientific notation? They're all significant. Okay, what about this guy? That guy has 3. Why? These trailing zeros, do they matter? Nope, because there's no decimal, but here there is a decimal. Therefore, how many are there? 5. Cool, questions about that? Awesome, so now let's do you guys did this, right? All right, let's talk about it. So, 100 times 40. Let's see, I'm going to say equals, what did I put? Okay, do you believe me? Yeah. Okay, so when I'm doing multiplication and division, my answer can only have as many significant figures as the fewer of the things I started with. I know it's hard to say in English. We need to come up with a better word for it. But, so how many significant figures here? 3, because there's a decimal. And how many here? 1. So my answer can only have 1, so I'm good to go. What's up? Awesome. Good? Okay, this one right here. Would you believe me if I said the answer was 53? Yes. Awesome. Who said no? Like that person at conference who's like, any opposed? Oh! Okay. So I'm adding 53 plus 0.4. I plug it in my calculator, I get 53.4, right? Well, in addition and subtraction, I don't care how many significant figures I have. Doesn't matter. What matters is where those significant figures fall in the number. Okay? I can only be as specific. By specific, I mean I can only go as far as whichever one of these goes less far. Okay? So, 53 goes to the ones place, right? 0.4 goes to the tenths place. Which one is more specific? A or B? B is more specific. A is less specific. So I can only go as specific as my less specific number. Okay? So I can only go to the ones place, so I round to the ones place, and I get 53. Yeah?
In other words, go cheap.
Yeah, so if I say what's 1,000, do I have that one on here? Oh no, we'll do that one. Okay, so let's keep going. This guy right here, I got, what did I say? I said 1,000. Is that what anybody else got? Yeah. Okay, because now I'm doing 2 operations. So I do the first operation and then adjust for significant figures and then do the second operation. I only have to do that if I'm combining multiplication and addition. Does that make sense? So, or when I'm changing rules. So I multiply these together and what do I get? 60.375 times 0.4361. And I got 26 point something. I'm going to write it. 60.375 times 0.4361 gives me 26.3295. Cool. Well, this is multiplication, so which rules do I follow? The fewer, whichever one has fewer sig figs. This one's got 4, this one's got 5, so my answer can only have 4, so this becomes 3. Have I lied to you? Okay, just yell if I'm lying. You'll know because everybody looks around like, and then you can yell, okay? So then I take 26.33 and add 1,000 to it. And I get 1026.33. This is specific to the hundredths place. This is specific to what? The thousands place. So my answer can only be to the thousands place, and I get 1,000. Okay? It seems stupid, right? Like I'm adding something to 1,000 and getting 1,000. But what these significant figures tell me is that I don't know that that's a 0. And if I don't know that that's, because I'm rounding to the nearest 1,000. If I don't know that's a 0, I don't know that's a 6. So I can't say it's a 6. Does that make sense? That's why we have this, okay? Now the second one, we put a decimal here. Now what? Well, now this is specific not to the thousands, but to the ones. So my answer can be specific to the ones. And my answer is 1,026. Yeah? Sweet. Let's keep going. All right, we got some dimensional analysis. Who's pumped? Okay, so your job is to find how many silver atoms are in 12 milligrams of silver. Okay, and if you want to keep going, that's fine, but we'll do this one and then this one.